In this question, a car is coming to a complete stop, and the rate of slowing down was taken as acceleration A equal to minus 0.50 meter per second square, and the initial velocity to start with before stopping is 75 kilometer per hour. Let's change this one to meter per hour, so multiply by 1,000 meter in 1 kilometer, and to take off the hour, so we have in 1 hour we have 360 3600, sorry, seconds, and this will yield a velocity or a speed of 20.83 meter per second. All right. The question is asking us in part A, find the distance before the car needs to travel before it comes to a complete stop. So delta x equal to what? And in part B, they're asking to find the time it took before it comes to complete stop. And in part C, he wants the distance traveled in the first second of slowing down, and same thing delta x in the fifth second of slowing down. All right. So let's start with part A. Delta x, we know that to find the distance, so we know that v final squared equal v initial squared plus 2a delta x. This solve for delta x algebraically first, and then you substitute the numbers. That's always the best option. So substitute the numbers. The final speed was 0, and the initial speed we found to be 20.83 meter per second. Don't forget to square the whole v. Divide by 2, multiply by minus 0.50 meter per second square. Remember, the car is slowing down, so it's a minus sign here. To plug in these numbers, you get a value of 442, this is 2.6 meter. And because we have two significant figures in our question, then our answer cannot exceed the two significant figures, so it's going to be 430 meter. This is for part A. For part B, we need to find the time it took for the car to stop completely. I'll just skip this one. Okay. So here's part B. We need to find the time. Well, we also know V final equal to V initial plus A t. We know final speed was 0, initial speed is 20.8. We know the A, we can find t. So really, if we solve for t, it's going to be V final minus V initial over the acceleration, and this is equal to, when we plug in the numbers, you're going to have the time in two significant figures, 42 seconds. Now for part C, see if I can write it here. For part C, he wants the distance traveled in the first second and in the fifth second. So I know the distance traveled is V initial t plus half a t squared. The initial velocity is 20.83 meter per second, which we already have. The time I'm looking for is the period it took to make that change in a distance. So the period is 1 second, because 0 t equals, time clicks from t equals 0, and then after 1 second I need to find the distance delta x. So really delta x is going to equal to the speed I already have, initial speed 20.83 meter per second, multiplied by the period. He wants the first second. This means the time period is 1 second plus half a minus 0.5 meter per second square multiplied by the period of time it took, which is 1 second again. And when you plug in these numbers, you get a value of 21 meter for two significant figures. So with an approximation here. Now the same question is asked, but now we need the distance traveled in the fifth second. Well, guess what? I'm gonna use the same formula here, all right? Except now my I'm looking for the same thing, the distance traveled in the fifth second. So the period it took to travel gonna be if you think of the period before the fifth second gonna be the only during the fifth second. This means I need to find the initial speed just at the fourth second. Because I'm looking here at during the fifth second, the period of time here then is going to be 1 second again, but it is from the fourth second to the fifth second. That will be the t period. This means the v here is unknown for me, and I need to find what is this v initial. So v initial here can be found at the fourth second. So v at the fourth second, 4 seconds, okay, this is going to be the v final equal to v initial plus at. And v initial, remember, it's the 20.83 meter per second, and it was slowing down with the rate minus 5.5 meter per second square, multiplies by the time it took, which is the 4 seconds, right? So I'm looking for the speed at the 4 seconds. So multiplies by 4 seconds here. So this value will give you a number of 18.8 meter per second. Now this V final at the 4 second, it's a final if you compare it to the initial speed of 20.83. But this for V at 4 second really is the initial speed if you compare it to the fifth second. So I come back here to delta x, the distance traveled during the fifth second gonna be the speed at the fourth second, 18.8 meter per second, times the period of time it took to from the fourth to the fifth second. The period of time is 5 minus 1 second, just 1 second again, plus half a times the period it took, again it's 1 second square. And when you plug in these numbers, you get a value of 18.6 meter. And because again we have two significant figures, then our value is going to be around 19 meter. So the point here I want to emphasize is that the V at 4 seconds, it can be final if you compare to the initial time, and it can be initial if you compare to the later time. And I just want to mention part C. There's many ways to solve this problem, but this is the route I took. You can try different routes as well. Thank you.